All right, so what you're trying to find out today is this. It's partially a history lesson. I'm going to take you back in time to what it used to be like to be in this class. Once upon a time, okay, these things, okay, graphing calculators didn't exist. There was no such thing as a graphing calculator. And because of that, this lesson became really, really hard for students to learn. Okay, it was hard for the teachers to teach it, it was hard for the students to learn it. So part of this you're going to do is like old-time math, okay? What used to be done in this class, but you guys have an advantage because it's a graphing calculator. We'll talk about that in a few minutes. Okay, so here comes the first thing. What you're trying to find out is this. What are the rational zeros for a polynomial equation? And so it's telling you here, if f of x equals a sub n x sub n plus dot 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 plus a sub 1x plus a sub naught. Okay, to find the rational zeros, what you have to do is one of two things. Divide p by q, which is the way some mathematicians talk about it. Or the other way of saying it is divide the factors of a sub naught by the factors of a sub n. Now already some of you guys are looking at me like, what does that all mean? Okay, well now here we go. This is simple. A sub naught, okay, or p, right, is the last number in the equation. Okay, so look here, we got 12 right there. Over a sub n is 1, the first number. Okay, which is also q, right? So you put 12 divided by 1 on the paper. Okay, now look, here's what you want to say to yourself. What are the numbers multiplied together that give you 12? Okay, so what? 1 times 12. 1 times 12 gives me 12. 2 times 6 and 3 times 4 give you 12. Makes sense? But it's not just positive and positive, it's also the negatives, right? So you understand what I have up here. Plus or minus 1, plus or minus 2, and 3, and 4, and 6, and 12. Multiplied together, they give you the number 12. Okay, now go to the bottom of this. What two numbers multiplied together give me positive 1? Now, plus or minus 1 is either 1 times 1 or negative 1 times negative 1. Make sense so far? Okay, so now your job is to find out the possible rational zeros that could exist. Okay, so this is easy. Let's take 1. Plus or minus 1 divided by plus or minus 1 gives you what? Plus or minus 1. See, this one's easy. The first one's easy on purpose to get you used to this. Okay, plus or minus 2 divided by plus or minus 1 is what? Plus or minus 2. Okay, plus or minus 3 divided by plus or minus 1 is what? Plus or minus 3, and so on and so on. So then, in other words, what you get is this. You get, these are the numbers, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. These numbers could be rational zeros for this equation that's up here, or this one right here. Okay, those could be the rational zeros. Okay, so now here for B, right, we've got the same situation. What are the possible zeros? Okay, so here's what you got. You got P over Q, right? The P is negative 10 over the Q is 4. Okay, now tell me, what two numbers multiplied together give you positive 10, I'm sorry, give you negative 10? And you see the answer is plus or minus 1, plus or minus 2, plus or minus 4, 5, and plus or minus 10. Okay, so is everybody good so far? Okay, and then over, and now we got 4. Plus or minus 1, plus or minus 2, plus or minus 4 make up the number 4. Everybody understanding so far? Okay, all right, so far so good. This box obviously is okay also, so it's true. That's something I wrote 3 hours ago. All right, so very good. All right, now, our job is to figure out now, what are the possible zeros, right? Okay, what are the possible zeros? Okay, so let me ask you this. Do you have any idea what the maximum number of zeros are on this? It's 12. Okay, so 12 is a good try, but it's not 12. Almost. How'd you get the number 12? Bingo. That's a good job. 4 times 3 gives you 12. Except the only thing is, it's plus or minus. So it would be 12. It would be... No. 24. There are 24 combinations of numbers here right now. Okay, yeah, exactly. That's how nasty this thing gets. There are 24 possible answers. Okay, so now we're going to go through this. Here we go. Okay, so here's 1, right? 1 over 1 gives you 1. Okay, that's easy. 1 over 2 gives you 1/2. Good. 1 over 4 gives you 1/4. Okay, that takes care of the 1s. Okay, now let's go to the 2. 2 over 1 gives you 2, plus or minus 2. 2 over 2 gives you 1. Oh, but wait, I already got 1. I don't have to write it down. See, some of them are going to double up. Okay, 2 over 4 gives you 1/2. We don't have to write that down. I already got 1/2. Okay, let's go to 5. 5 over 1 gives you 5. We've got to write that one down. 5 over 2 gives you 5/2. Right, we've got to use fractions on this. 5/2. Okay, 5 over 4 gives you 5/4. Okay, so 5/4 is a possible answer. Okay, so we got the 5 taken care of. Okay, let's go to the 10. 10 over 1 gives you 10. Okay, so 10 over 1. Okay, 10 over 2 gives you 10 over 2 gives you 5. Right, 5, but we already got 5. Okay, 10 over 4 gives you 5/2. Right, 10/4, which is 5/2. But we already got that, right? There you go. There are the answers, and we did them all. So this is the answer to that problem. What are the possible zeros? Okay, there they are right there. We're going to stop the tape. Okay, so here's example number 2. Now, on example 2, first of all, you're going to say, okay, look, here we got P over Q, which is 20 over 1, right? Okay, so tell me, what are the combinations of 20? And you go like, well, plus or minus 1, 2, 4, 5, 10, 20. And then what are the combinations for 1? Well, that's easy, plus or minus 1. Okay, so now here, you can tell me this now. The possible zeros, okay, are going to be what now? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. See, it's always an easy problem. When you put 1 on the bottom, it makes it super easy. It's like, oh, that's easy, I can do that. Okay, so everybody understands so far? Okay, now here's the thing, but what now you got to figure out is this. How many of those are going to be good answers? How many of those are going to be good answers? No, how many are going to be good answers? 3, right, there are 3 good answers here. Okay, so now here's what you're going to do. Go to your calculator and go type in this equation. Y equals x cubed minus 8x squared plus 11x plus 20. This one the calculator helps us, which we couldn't do many years ago, right? Okay, now we can. What's that? Yeah, oh yeah. You can use a calculator to do these. Oh heavens, no. When I was your age, the scientific calculator was not even created yet. Yeah, it was all by paper and pencil. There's no such thing. It's a scientific. That shows how old I am. Yeah.
Are you still wanting to be on?
Oh yeah, okay. All right, so very good so far. All right, now here's the thing. Did you graph it?
Oh,
Go graph it. Go graph the equation.
whoa.
Okay. All right, yeah. Right now, look at the graph. How many times does that graph touch the x-axis? 3 times, which says there are 3 zeros. Make sense? So you guys all know that. All right. Okay. Well, then you typed something in wrong. I don't know what you did. Go back and look at your equation. Because that should have come out to be 3 zeros. Okay. Okay. Now here's the next thing. You're going to tell me. Look at the graph and tell me the zeros. Okay, but wait. There's an easier way. Everybody go to the table. Go to the table. Go to the table and look for what x you get on y, which is 0. -1. Now stop. Okay, -1 is one of them. You're right. Okay, now here's what you're going to show me on the paper. So you're going to go and put -1 in the box. Okay? All right, and now you're going to put down your numbers, right? 1, -8, 11, and 20. Okay, and now you're going to do your synthetic. So 1, -1, -9, 9, 20, -20, and sure enough, you get 0. And that's how you prove to me that that's a 0, like that. Okay, so I understand it so far. Once again, this is old stuff. Okay, no, just leave it like this. Okay, now, all right, so you're very good so far. All right, now look at the table again. Is there another 0? All right, 4. All right, now here's the thing. There's two choices here. Okay, one would be to go put 4 in this and do this whole thing again. But does it make sense to you that if 4 can go into this, then 4 could go into what's left over here, right? Make sense? So just take what's left over and do 4 with it, right?
Even a 0?
So 1 and 4 and -5 and -20. You're right. It works there also. You see? Now we got that. What's that? Well, because the thing is, the zeros tell you the factors, right? And the factors all multiplied together give you the beginning equation. So you know that if a factor can go into the beginning equation, it can go into anything else that's broken down. It's just common sense math. Okay? Okay, there you go. You're good. Okay. All right, so now we're over there. Okay, now what's the next 0? 5. Okay, so now we're going to go here again, and here, let me choose my color. And now we're going to put a 5 in with what's left over. So look, 1, 5, and 0. Oh my gosh, you're right. So I just proven that -1, 4, and 5 are all zeros. Because this one gives me a 0, and this one gives me a 0, and this one gives me a 0, right? Okay. Okay, and so now you're ready to declare the answer, right? So you can say, okay, the zeros, right, or solutions, what are you going to say, are these numbers, -1, 4, and 5, okay? And you've got the answer. Okay, so let's go to the next problem. Okay, so here's the next one, right? Okay. So once again, we're doing P over Q, right? And let's stop right there. Okay, all right, so here are the possible zeros when you get this, right? Now, if you know how to do it, I don't know if everybody knows how to do that. See, that's the thing. Okay. All right, so you go to 1/5, right? And then what you have to do is put the numbers down, right? So we got 10, -11, -42, and 7 and 12, right? Okay, and now does that give you 0? Did you do 1/5? You got one? Why is it?
3/5.
Okay, so you think 3/5 is one? Okay, all right, well we'll try 3/5 then, because we got somebody. Okay, so let's try 3/5, okay? Okay, all right, so look, here we go. So we're going to go 10, right? Okay, now what's 3/5 times 10? 6. Now what's -11 and 6?
-5.
-5. What's 3/5 and -5?
A number.
-3. What's -3 and -42? -45. What's -45 times 3/5?
15.
-27.
-27. What's -27 and 7?
-20.
Okay, what's -20 and 3/5?
-12.
Oh my gosh.
That was right.
You are right. It is that. It is that. You got one. Okay. Okay, all right.
Another one.
Okay, is it -1/2? Okay, so here's -1/2. Okay, so here we go. So 10, -5, -10, 5, -40, okay, 20. You know what? You're right. It is -1/2. You got it. It works. Okay, so now we're going to do 12/5 because it's all right. Okay, so here we go. So we got 10, right? Okay, and then what's 12/5 times 10? 24. And then that's going to give you 14. And what's 12/5 times 14? 12/5 times 14, yeah. How much is that? 33.6. 33.6. Well, that's not it. That doesn't work. Alright. So what you gotta do is this then. Okay. It is done. Alright. Here's what you're gonna have to go to next. You're gonna have to go and use the quadratic formula to find the other two zeros. And that's what we're gonna start doing come tomorrow. That's tomorrow. So, well, this one, that's the purpose of what we did. To show you that not only come out the jar. Okay, no, it's okay. It's okay. You do. Your rationals are this and this.
We only do
Yeah, and for the days homework is
Mark,